This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Efkan Efe. 20,000 Leagues Under the Seas by Jules Verne. First part, Chapter 12. Everything Through Electricity. "Sir," Captain Nemo said, showing me the instruments hanging on the walls of his stateroom. "These are the devices needed to navigate the Nautilus. Here, as in the lounge, I always have them before my eyes, and they indicate my position and exact heading in the midst of the ocean. You are familiar with some of them, such as this thermometer, which gives the temperature inside the Nautilus, the barometer, which measures the heaviness of the outside air and forecasts changes in the weather, the humidistat, which indicates the degree of dryness in the atmosphere, the storm glass, whose mixture decomposes to foretell the arrival of tempests, the compass, which steers my course, the sextant, which takes the sun's altitude and tells me my latitude, chronometers, which allow me to calculate my longitude, and finally spyglasses for both day and night, enabling me to scrutinize every point of the horizon once the Nautilus has risen to the surface of the waves." "These are the normal navigational instruments," I replied, "and I am familiar with their uses. But no doubt these others answer pressing needs unique to the Nautilus. That dial I see there, with the needle moving across it, isn't it a pressure gauge?" "It is indeed a pressure gauge. It is placed in contact with the water, and it indicates the outside pressure on our hull, which in turn gives me the depth at which my submersible is sitting. And these are some new breed of sounding line. They are thermometric sounding lines that report water temperatures in the different strata. And these other instruments, whose functions I can't even guess. Here, Professor, I need to give you some background information," Captain Nemo said. "So kindly hear me out." He fell silent for some moments. Then he said, "There is a powerful, obedient, swift, and effortless force that can be bent to any use, and which reigns supreme aboard my vessel. It does everything. It lights me, it warms me, it's the soul of my mechanical equipment. This force is electricity." "Electricity?" I exclaimed in some surprise. "Yes, sir. But, Captain, you have a tremendous speed of movement that doesn't square with the strength of electricity. Until now, its dynamic potential has remained quite limited, capable of producing only small amounts of power." "Professor," Captain Nemo said, "my electricity isn't the run-of-the-mill variety, and with your permission I'll leave it at that." "I won't insist, sir, and I'll rest content with simply being flabbergasted at your results. I would ask one question, however, which you needn't answer if it's indiscreet. The electric cells you use to generate this marvelous force must be depleted very quickly. Their zinc component, for example. How do you replace it, since you no longer stay in contact with the shore?" "That question deserves an answer," Captain Nemo replied. "First off, I'll mention that at the bottom of the sea there exist veins of zinc, iron, silver, and gold whose mining would quite certainly be feasible. But I've tapped none of these land-based metals, and I wanted to make demands only on the sea itself for the sources of my electricity." "The sea itself?" "Yes, Professor, and there was no shortage of such sources. In fact, by establishing a circuit between two wires immersed to different depths, I'd be able to obtain electricity through the diverging temperatures they experience, but I preferred to use a more practical procedure." "And that is?" "You are familiar with the composition of salt water. In 1000 grams one finds 96.5% water and about 2.66% sodium chloride. Then small quantities of magnesium chloride, potassium chloride, magnesium bromide, sulfate of magnesia, calcium sulfate, and calcium carbonate. Hence you observe that sodium chloride is encountered there in significant proportions. Now then, is this sodium that I extract from salt water and with which I compose my electric cells. Sodium? Yes, sir, mixed with mercury. It forms an amalgam that takes the place of zinc in Bunsen cells. The mercury is never depleted, only the sodium is consumed, and the sea itself gives me that. Beyond this, I'll mention that sodium batteries have been found to generate greater energy, and their electromotor strength is twice that of zinc batteries. Captain, I fully understand the excellence of sodium under the conditions in which you are placed. The sea contains it. Fine. But it still has to be produced, in short, extracted. And how do you accomplish this? Obviously, your batteries could do the extracting, but if I am not mistaken, the consumption of sodium needed by your electric equipment would be greater than the quantity you'd extract. It would come about, then, that in the process of producing your sodium, you'd use up more than you'd make. According to Professor, I don't extract it with batteries. Quite simply, I utilize the heat of coal from Earth. From the Earth? I said, my voice going up on the word. We'll say coal from the seafloor, if you prefer, Captain Nemo replied. And you can mine these veins of underwater coal? You'll watch me work them, Professor Aronnax. I ask only a little patience of you, since you'll have ample time to be patient. Just remember one thing. I owe everything to the ocean. It generates electricity, and electricity gives the Nautilus heat, light, motion, and in a word, life itself. But not the air you breathe. Oh, I could produce the air needed on board, but it would be pointless, since I can rise to the surface of the sea whenever I like. However, even though electricity doesn't supply me with breathable air, it at least operates the powerful pumps that store it under pressure in special tanks, which, if need be, allows me to extend my stay in the lower strata for as long as I want. Captain, I replied, I'll rest content with marveling. You've obviously found what all mankind will surely find one day, the true dynamic power of electricity. I'm not so certain they'll find it, Captain Nemo replied icily. But be that as it may, you are already familiar with the first use I've found for this valuable force. It lights us, and with a uniformity and continuity not even possessed by sunlight. Now look at that clock. It's electric. It runs with an accuracy rivaling the finest chronometers. I've had it divided into 24 hours like Italian clocks, since neither day nor night, sun nor moon, exist for me, but only this artificial light that I import into the depths of the seas. See, right now it's 10 o'clock in the morning. That's perfect. Another useful electricity, that dial hanging before our eyes, indicates how fast the Nautilus is going. An electric wire puts it in contact with the patent log. This needle shows me the actual speed of my submersible. And hold on. Just now we are proceeding at the moderate pace of 15 miles per hour. It's marvelous, I replied, and I truly see, Captain, how right you are to use this force. It's sure to take the place of wind, water, and steam. But that's not all, Professor Aronnax, Captain Nemo said, standing up, and if you'd care to follow me, we'll inspect the Nautilus's stern. In essence, I was already familiar with the whole forward part of this underwater boat, and here are its exact subdivisions, going from amidships to its spur, the dining room, 5 meters long, and separated from the library by a watertight bulkhead. In other words, it couldn't be penetrated by the sea. The library, 5 meters long, the main lounge, 10 meters long, separated from the captain's stateroom by a second watertight bulkhead. The aforesaid stateroom, 5 meters long, mine, 2.5 meters long, and finally air tanks, 7.5 meters long and extending to the stem post. Total a length of 35 meters. Those were cut into the watertight bulkheads and were shut hermetically by means of India rubber seals, which ensured complete safety aboard the Nautilus in the event of a leak in any one section. I followed Captain Nemo down gangways located for easy transit, and arrived amidships that I found a sort of shaft heading upward between two watertight bulkheads. An iron ladder, clamped to the wall, led to the shaft's upper end. I asked the captain what this letter was for. "It goes to the skiff," he replied. "What, you have a skiff?" I replied in some astonishment. "Surely, an excellent longboat, light and unsinkable, which is used for excursions and fishing trips." "But when you want to set out, don't you have to return to the surface of the sea?" "By no means. The skiff is attached to the topside of Nautilus's hull, and is set in a cavity expressly designed to receive it. It is completely ducked over, absolutely watertight, and held solidly in place by bolts. This ladder leads to a manhole cut into the Nautilus's hull, and corresponding to a comparable hole cut into the side of the skiff. I insert myself through this double opening into the longboat. My crew close up the hole belonging to the Nautilus. I close up the one belonging to the skiff, simply by screwing it into place. I undo the bolts holding the skiff to the submersible, and the longboat rises with prodigious speed to the surface of the sea. I then open the deck paneling, carefully closed until that point. I upmast and hoist sail, or I take out my oars, and I go for a spin. "But how do you return to the ship?" "I don't, Professor Aronnax. The Nautilus returns to me." "At your command?" "At my command. An electric wire connects me to the ship. I fire off a telegram, and that's that." "Right," I said, tipsy from all these wonders, nothing to it. After passing the well of the companionway that led to the platform, I saw a cabin 2 meters long in which Conseil and Ned Land, enraptured with their meal, were busy devouring it to the last crumb. Then a door opened into the galley, 3 meters long and located between the vessel's huge storage lockers. There, even more powerful and obedient than gas, electricity did most of the cooking. Arriving under the stoves, wires transmitted to platinum griddles a heat that was distributed and sustained with perfect consistency. It also heated a distilling mechanism that, via evaporation, supplied excellent drinking water. Next to this galley was a bathroom, conveniently laid out, with faucets supplying hot or cold water at will. After the galley came the crew's quarters, 5 meters long, but the door was closed, and I couldn't see its accommodations, which might have told me the number of men it took to operate the Nautilus. At the far end stood a 4th watertight bulkhead, separating the crew's quarters from the engine room. A door opened, and I stood in the compartment where Captain Nemo, indisputably a world-class engineer, had set up his locomotive equipment. Brightly lit, the engine room measured at least 20 meters in length. It was divided by function into 2 parts. The first contained the cells for generating electricity, the second that mechanism transmitting movement to the propeller. Right off, I detected an odor permeating the compartment that was sui generis. Captain Nemo noticed the negative impression it made on me. "That," he told me, "is a gaseous discharge caused by our use of sodium. But it's only a mild inconvenience. In any event, every morning we sanitize the ship by ventilating it in the open air." Meanwhile, I examined the Nautilus's engine with a fascination easy to imagine. "You observe," Captain Nemo told me, "that I use Bunsen cells, not Ruhmkorff cells. The latter would be ineffectual. One uses fewer Bunsen cells, but they are big and strong, and experience has proven their superiority. The electricity generated here makes its way to the stern, where electromagnets of huge size activate a special system of levers and gears that transmit movement to the propeller's shaft. The latter has a diameter of 6 meters, a pitch of 7.5 meters, and can do up to 120 revolutions per minute. And that gives you a speed of 50 miles per hour. There lay a mystery, but I didn't insist on exploring it. How could electricity work with such power? Where did this nearly unlimited energy originate? Was it in the extraordinary voltage obtained from some new kind of induction coil? Could its transmission have been immeasurably increased by some unknown system of levers? This was the point I couldn't grasp. "Captain Nemo," I said, "I'll watch for the results and not try to explain them. I've seen the Nautilus at work out in front of the Abraham Lincoln, and I know where I stand on its speed. But it isn't enough just to move. We have to see where we are going. We must be able to steer right or left, up or down. How do you reach the lower depths where you meet an increasing resistance that's assessed in hundreds of atmospheres? How do you rise back to the surface of the ocean? Finally, how do you keep your ship at whatever level suits you? Am I indiscreet in asking you all these things? Not at all, Professor, the captain answered me after a slight hesitation. Since you'll never leave this underwater boat, come into the lounge. It's actually our workroom, and there you'll learn the full story about the Nautilus. End of chapter 12. Recorded by Efkan Efe. 1st of April 2006. İzmir, Turkey.